Hey class, we're going to learn how to do synthetic substitution. It's kind of a neat way to evaluate a polynomial, and it'll also help us with synthetic division later on in the unit. So synthetic substitution is just another way to evaluate a polynomial. So the steps for synthetic substitution: you want to place the x value on the outside. List all the coefficients in descending order. Coefficients are the numbers in front of the variables. And then descending order means based on their exponent value. So from highest exponent to lowest, those coefficients. And then we solve we bring down the leading coefficients, and then we multiply, add. So my students like to remember this step last year as drop mama. So we're going to drop mama. This is going to make more sense once we actually do it. So synthetic substitution is an alternative method to evaluating this function, f of x equals 5x cubed plus x squared minus 4x plus 1 when x equals 4. So I want to use synthetic substitution to figure out what f of 4 is. So if I was to plug in 4 for all of the x's and get this result. But instead of doing it that way, we're going to use synthetic substitution. So first, 4 goes on the outside like this. Then I list the coefficients from the highest exponent to the lowest. I have an x cubed, an x squared, an x, and then my constant. So my coefficients are 5, then 1, then -4, and then 1. And then here's drop mama. So we drop down the first one, and then we multiply. So drop down the 5. Then we multiply the 4 times the 5. So 4 times 5 is 20. That goes here. Then we add. 1 plus 20 is 21. Okay, so drop it down, multiply, add. Now we're at multiply again. So now we take the 4 times the 21. 4 times 21 would be 84. And then add. -4 plus 84 is 80. And then multiply one more time. 4 times 80. 4 times 8 is 32, so 320. And then add 320 plus 1 is 321. And so that, if we were to evaluate here, that's the answer we should get. So just to show you how that works, we'll plug it into the calculator just to make sure we're correct. So 5 times 4 cubed plus 4 squared minus 4 times 4 plus 1 gives us the value of 321. So the function evaluated at 4 equals 321. So with synthetic substitution, I was able to do that without a calculator pretty easily. Like, I had to multiply 21 and 80 by 4, but it wasn't too difficult. If I was doing this method, I'd have to take 4 cubed, then times that by 5, then add that to 16, and so it's not as easy without a calculator especially. So as the exponents get larger, synthetic substitution is really helpful. Let's try another one. One thing with synthetic substitution is you do have to have a coefficient for every term. And so if I want to find here, I want to evaluate this function for 2. So I have x to the 6th power. So this is a 6th degree polynomial, which means that I have to have a coefficient for x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x squared, and x, and a constant in order to synthetically substitute. So I have an x to the 6th, but I have 0x to the 5th, 0x to the 4th, 0x cubes, 0x squareds, and then I have a 3x and then a plus 4. So when I set this up, 2 on the outside, and then all of these coefficients, I have to add in the zeros. So 1 0.000034. So I have to have a spot for every polynomial from the highest exponent all the way down to the constant term. If the constant is missing, I also have to add a 0 there. Then we drop it down, and then multiply, add. So drop mama. So drop down the 2, or the 1, then multiply the 2 times this number. So 2 times 1 is 2, that goes here. Then you add, 0 plus 2 is 2. Then you multiply, 2 times 2 is 4. And then we put the 4 there, then we add, 0 plus 4 is 4. Then we multiply again, 4 times 2 is 8, 0 plus 8 is 8. Then we multiply, 8 times 2 is 16, that goes here, 0 plus 16 is 16. Then we multiply again, and 2 times 16 is 32, that goes there. Then we add, 32 plus 3 is 35. Then we multiply, 2 times 35 is 70. 70 plus 4 is 74. So that should be our answer of the function evaluated at 2 is, 74. So in this particular case, it might have just been easier to plug in 2 to the 6 plus 3 times 2 plus 4. And either method is acceptable, but we're practicing the synthetic substitution. So that's how you would do it. It would give you the same answer. Okay, so this is a 5th degree polynomial on this one. We have an x to the 4th, but we are missing a 0x cubed and a 0x squared. So you will have to add in the zeros for those 2 spots, and that'll go between the 4th power and the 1st power. So if I want to evaluate for -1, I'm going to put -1 on the outside, then list my coefficients. So 3, -1, then 0, 0, -5, 10. So 3, -1, then 0, 0, -5, and then 10 is the constant. Drop down the first one, multiply, -1 times 3 is -3, then add, -1 plus -3 is -4, then multiply, -1 times -4 is 4, add, 0 plus 4 is 4. Multiply, -1 times 4 is -4, add, 0 plus -4 is -4. Multiply, -1 times -4 is +4, add, -5 plus 4 is -1, multiply one more time, -1 here times -1 is +1, it goes right here with the 10. 1 plus 10 is 11. So the function evaluated at -1 is 11. All right. We'll evaluate the next one for 2. So same function. So we start the same way. Drop it down. Multiply. 2 times 3 is 6. Add, we get 5. Multiply, you get 10. Add, multiply, you get 20. 0 plus 20 is 20. Multiply by 2 again, you get 40. Add, you get 35. Multiply by 2, you get 70. Add, you get 80. That is our final answer. So the function evaluated at 2, or when you plug 2 in for x, the output is 80. So when x equals 2, y equals 80. Okay, that's all I have for you. So hopefully that was enough examples. We'll practice this in class more. So thank you.